So we talked about building an atom of sodium in the previous presentation, and we talked about the protons and neutrons being in the nucleus, and then the electrons going around the outside. Now, there's a little slight level of complication here, and that is that on this diagram here, you can see pretty nicely. Get this to work. Here we go. Oops, sorry. That the nucleus is in the center of the atom here, and the electrons, though, do not just all go around the outside wherever they want or in one kind of big cloud. They're actually spaced out in these kind of orbitals around the nucleus. So you can think of it a little bit like tracks on a lanes on a running track. So there's the center of the running track, and then there's the inside lane, and then the next lane, and the next lane. And the runners have to stay within their in their lane when they run a sprint around the track. And that's the same with the electrons that orbit the nucleus. And so there's also the electrons have specific places where they have to remain as they orbit the nucleus of the atom. And we call these orbitals or energy levels or shells. So there's some specific rules about where these electrons can be, and they kind of follow a general pattern, which says that the first energy level, which is the closest one into the nucleus, only 2 electrons can fit in that. So it can be less than 2, it can be 1 if there's only 1 electron, but then if there's any more than 2 electrons, they can't fit in this. They can't fit in this for a shell. So you have to go out to the next kind of racetrack around to the second level, second energy shell. And in this second energy shell, you can fit up to 8 electrons. So up to 8 can fit in here, and then the next level can fit up to 8 as well. So 2 in the first, 8 in the next, and 8 in the next. Now, you don't, when you're building an atom or an atom is built, you can't just put the electrons wherever you want. You have to put them in the closest in shell that you can. There's still space. So you put the first one here, the second one here. Once that's filled, you start going to this one. And then you go to the, you put in the next one until you fill this one up with 8. And then if you still had even more electrons, you go out to the next shell where you could fit another 8. So that's, the electrons are placed in these specific shells or orbitals. So in the next slide, we're going to go through how you would actually do that for sodium. So once again, we got the same sodium that we had before. Let me go back here to black. And we already learned that inside of the nucleus, we're going to have 11 positively charged protons. And we're going to have 12 neutrons that have no charge. All right, so I'm just going to draw a circle around that, and that's going to be my nucleus. All right, now we have 11 electrons that this atom needs to balance out the 11 protons. And so instead of just putting them in the, around the outside like I did before, we are going to put them in their shells. So I'm just going to draw a circle to show the shell. And in this first shell, remember, we can put up to 2 electrons. So I'm going to show the electrons like little blue dots. We could have 1, 2, and you can draw them wherever you want. I'm just going to draw them there. I could put like an E minus so that you know that it's an electron. All right, so there's 2, but I'm supposed to put 11, but the first shell is already full with 2, so I'm going to have to go out here and make another shell. So my diagram is going to get pretty hairy here, but I'm going to make another shell. And in this second shell, remember the rules are we can put up to 8. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. So altogether now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 in the first shell, 8 in the second shell. That's 10. But again, I need 11. So I still haven't got enough electrons. What am I going to do? I'm going to have to make another shell to fit the 11th one in. So I'm going to have to build another shell. It would be nice and circular, but I can't draw very well. And we're going to put our last electron right here. So this, what I just drew here, is what we would call a Bohr model. It's named after the famous Danish physicist who was the first guy to kind of figure this out, Niels Bohr. And this is how I would draw a Bohr model or a Bohr diagram of an atom of sodium using information from the periodic table. All right, now that took a lot of time and it's kind of messy. It does have a lot of information in it, it's true. But there's also another way that we show atoms in a more shorthand way, because actually what really matters in an atom is the outermost shell. So if you imagine, if I bring two things together and they start to interact, the first part that touches from this atom and this atom is the outer shell. They're going to start interacting with each other. And chemistry is really the study of how atoms interact. So if we're really interested in how atoms are interacting, we want to be really interested in the very outermost shell. And so on this diagram here, the outermost shell is this, sorry, I think you can see that. The outermost shell is this one here. And there's only one single electron in it right here. And so we are going to draw a different way of showing an atom. We're going to just write Na for sodium. And sodium has a single electron in its outermost shell. So we're just going to do a single dot to represent the fact that this atom has a single electron in its outermost shell. This, what I just drew here, is called a Lewis dot diagram. Lewis is another chemist, and he came up with this dot way of showing just the outermost shell of an electron, of an atom. So the outermost shell of an atom actually has a name, and we call it the valence shell. It's like the valence, like that goes around the edge of a bed. Anything that goes around the edge of something, the valence or the valence shell. So we can say from this Lewis dot diagram that sodium has one valence electron. It's not true to say sodium has one electron. That's not correct, because if you look at the diagram, sodium has 11 electrons in total, but in terms of its outermost shell, it has one valence electron. All right, so I'm going to pause this video here for a few minutes, and I'd like you to draw both a Lewis dot diagram, a Bohr model with all the rings, and a Lewis dot diagram for aluminum. So